Okay, good morning everyone. Mr. Hakim here. This will be part 1 of chapter 6 chemical formula and equations for bridging. So for those that scored 50% and below for their end of year exams, this video will help you to strengthen your basics so that we will be able to tackle the next few chapters in Sec 4. Okay, so for those that are interested as well, there will be other videos for you to watch in this series, and I hope it will be useful for you. So again, for this, since this series will be about, or rather will be for the weaker students, I will be focusing on the very basics. So we will not tackle any difficult questions. We will only tackle the basic understanding, and if you want to tackle difficult questions, you can do it on your own from the worksheets that I've given you, as well as the textbook. And also you can take a look at your 10-year series to understand the types of rigor or the types of different questions that may come out for your O-levels next year. Okay? Alright, so let's begin. So there are 3 parts in this series. First part is what are chemical formula. Second part is how are chemical formulas constructed. And the third part is what are chemical equations and how do we balance them. This chapter is very important because I believe that since a lot of you are weak in this chapter, you are unable to do your mole calculations, you are unable to do your QA, you are unable to do your formation of ionic equations, so on and so forth. And because of that, you have lost a lot of marks for your end of year exams. So I hope that by going through this chapter again, you will be able to finally understand how to do the more difficult questions. Okay, let me change my lighting for a moment. Alright, I think this is better. Okay, so in this part, we will be talking about the state chemical symbols of elements and formula of compounds. Okay. So chemical symbols, we know that there are different types of chemical symbols, right? Okay, there is solid, there is also liquid, as well as gas. But there is also something called aqueous state, A-Q-U-A-U. And the aqueous state is something that a lot of people can get confused quite easily because it is neither solid, liquid or gas. Rather, aqueous state is usually used for ionic compounds when dissolved in water. Okay? So, let's keep this in mind first as we go through it. Okay? Alright, so firstly, what are chemical formula? We know chemical formula as representation of ratios of elements in a compound. Okay, remember that compounds are made up of 2 or more elements chemically combine together. In this case, the keyword is chemically combined together. Okay, and it has to be made of 2 or more elements chemically combined together. It means there is a bond between them. Bond. So the bond can come in the form of ionic bonds, covalent bonds, things like that. Okay. And then 2 or more elements. So basically, elements can be found in your periodic table. So for example, carbon is an element. In this case, carbon is an element. Oxygen is an element as well. And because these are 2 different elements, when they are placed in such image, okay, it shows that there is a bond between them. Okay, so let me use another color instead. So the orange arrows represent the bond. Okay, So in your other chapters, in your chemical bonding chapters, you know that between non-metals, what kind of bonds do they form? They form covalent bonds, right? Okay, so between oxygen and carbon, there is a covalent bond, and between carbon and another oxygen atom, it forms another covalent bond, and this whole carbon dioxide is what you call a compound. And if we were to simplify it in ratio, okay, remember in your mathematics, your ratio, one atom of carbon, so you can see there's only one atom of carbon, is to 2 atoms of oxygen. So if I were to put it in ratio, it is 1:2. Same thing for water. Oxygen is an element and hydrogen is an element. Again, they can be found in your periodic table. Once they are formed together or drawn in this case, there is a bond between them, and since both are non-metal elements, they will form a covalent bond. And if I were to put it in ratio, okay, so H is to O, it is 2:1. Okay, because there are 2 atoms of hydrogen to 1 atom of oxygen. Alright, so let's continue. So this is just the definition of what is a chemical formula. A chemical formula is like a recipe that shows the ratio of elements. Okay, so different ratios that are combined in one unit of a substance. Okay, and in this case, what substance we're talking about? We are talking about compounds. Okay, it is made up of chemical symbols that indicate the elements present, and also subscript indicating the number of atoms present. Subscript, if you do not know what it is, okay, subscript is the small number at the bottom of the symbol. So for example, okay, for water is H2O. This is your subscript. And what does this indicate? It indicates that there are 2 hydrogen atoms. Okay, so this indicates that there are 2 hydrogen atoms and 1 oxygen atom. So naturally there will be 1 here. Okay, but for oxygen we do not show the 1. Okay, so without writing it, we will assume that it's already 1. Okay, so don't have to get confused about that. Okay, so chemical formulas of compounds. Compounds are made up of atoms of elements that are chemically combined. Compounds have fixed formula. Okay, remember in your definition, you also learned it in Sec 1. Okay, compounds have fixed formula, means they cannot change. When water is H2O, it is always H2O. It is not H4O2. It is not H6O3, things like that. It is always fixed. Okay, so for example, ammonia, a compound that you need to know by now, especially for when you cover your QA, your qualitative analysis. It has a chemical formula of nitrogen and hydrogen, or NH3. So the question now I want to ask you is, what are the atoms present in the following substances? Okay, spend some time think about it, because I know some of you are still not so sure how to identify the different chemical, or rather the different atoms that are present. Okay, so let's take a look at ammonia. What are the atoms present in the following substances? For ammonia, let me erase this first. You have N. And N, if you take a look at your periodic table, it stands for nitrogen. You also have H. And H in your periodic table, it stands for hydrogen. So now if I were to put it in ratio terms, okay, N is actually, what is it? N1. And H is actually H3. So if I were to put in ratio, it's 1:2. 3. This indicates that there are 3 atoms of hydrogen and 1 atom of nitrogen. Okay, so ammonia is made up of 1 atom of nitrogen, 3 atoms of hydrogen. And if you want to know why, please go back to your chemical bonding chapter. Take a look at the valence electrons, okay, and see how ammonia is being formed between nitrogen and hydrogen. Okay. Next, let's take a look at copper 2 sulfate. Remember, the 2 here I've covered before. The 2 here represents the type of ion formed. Okay, so copper 2, okay, is a transition metal. Okay, you didn't learn it as a chapter, but you should be familiar with the term transition metals. Okay, so copper 2 is a transition metal, and it means that it forms a Cu2 plus ion. Okay, so let's take a look from the chemical formula. Here you have Cu represents copper. You have S, which is sulfur, as well as O. Okay, sorry, I think I write it here. O, you have oxygen. But take a look here. For oxygen, there is a small subscript of 4. What do you think that means? A subscript of 4. So if I were to write it in ratio, copper is actually Cu1, sulfur is actually S1, and O4. So it will be 1:1:4. Common mistakes that you might have done or committed is that you might think that the 4 for oxygen refers to sulfur as well. Okay, that is not true. Okay, I will tell you why later on. Okay, but for now, take note that the subscript 4 is for oxygen only, not for sulfur. Okay. Alright, can you do the rest for me as well? Okay, spend some time, maybe about 3 minutes, you should be quite fast. Do for sodium hydroxide, hydrochloric acid, and ethanoic acid. Okay, you can pause the video here, okay, and after that you can take a look at the answers afterwards. Okay, so the answers are for sodium hydroxide is 1:1:1, and A refers to sodium, so you remember in your periodic table, please be familiar with it. HCl is 1:1, okay, means there is 1 atom of hydrogen to 1 atom of chlorine. Ethanoic acid is a bit unique. Okay, the types of atoms present are carbon, hydrogen, and oxygen. Okay, even though they write it in this form, don't be deceived, it's actually O2. Okay, so it is, how many carbons are there? There's 2 carbons, 4 hydrogens, and 2 oxygen. Okay, so in this case, you don't have to simplify it because the chemical formula of ethanoic acid is as such. Okay, it's CH3COOH, 2 carbon, 4 hydrogen, 2 oxygen. Okay, you will learn more about ethanoic acid and other organic compounds next year. Alright, so take a look here. This is rather a summary of what you have learned. Okay, this is calcium nitrate. Okay, so if you remember, calcium nitrate, NO3 is, this is your nitrate ion. It is one of the polyatomic ions that you need to be familiar with. Okay, alright, so the subscript denotes that there are 2 nitrate ions in 1 unit of calcium nitrate, which means, just now remember I said this 3 belongs to only oxygen. Okay, these 2 means that NO3, this whole thing, times 2. So there's 2 of nitrate ions. Okay, alright, so there's 2 of nitrate ions. Okay, which means if I were to put it, how many atoms are there? Okay, there are 2. Sorry, let me write down here, and O. Okay, means there is 1 calcium, there is 2 nitrogen, and there is 6 oxygen. So remember your, I think indices, is it, in your mathematics? Okay, so you take 2 times 3, so it is 6 oxygen. So this is the ratio of atoms. Alright, Ken? So this is a summary of everything that you need to know how to. Alright, so take a look here. This is rather a summary of what you have learned. Okay, this is calcium nitrate. Okay, so